Hello everyone, in this video I'm going to discuss the example for limit. Kindly refers to A. Find the value A if the situation given. So focus on the left hand side. If we substitute the A, and we will have the situation square root of A minus the 2 over, we have the A minus the 4, where we have equals to 1 over 6. Next, focus on the A minus the 4. If we factorize the situation, and we will have square root of A minus the 2 over, we have the situation square root of A minus the 2 multiply with the square root of A plus with the 2, where we have 1 over 6. If we simplify the situation, and we will have 1 over the square root of A plus with the 2, where we have 1 over 6. So from here we can cross multiply, then we will have 6, where we have square root of A plus with the 2. So square root of A is equals to 4, then we have to square both sides, so A will be equals to 16. Next, kindly refers to B. The function fx is given. So my suggestion is to illustrate the situation in a real number line. So here we have the 0. So for the left hand side, where we have x less than 0, the function will be 1 minus 2 exponent 2x. If x is equals to 0, then the value of y will be equals to 1. Continue. We have the exponent 3x minus the 2 for the situation x greater than 0. Determine the existence of the limits of the fx as x approaching 0. So from here, we are going to find the limit when x approaching 0 from the left. So kindly refers to the number line, and we have the function 1 minus 2 exponent 2x. If we substitute 0, and we will have the value of y where we have approaching negative 1. Next, limit when x approaching 0 from the right. So the function will be exponent 3x minus the 2. If we substitute the 0, then we will have the value of y approaching negative 1 as well. So limit when x approaching 0 from the left for the function fx is the same for the limit when x approaching 0 from the right for the function fx. Since we have the same, then we can say limit when x approaching 0 for the function fx, which is equals to negative 1, or we can say approaching negative 1, and the limit exists. So continue. Number 2, determine whether the fx is continuous at x is equals to 0. Hence, state the interval where fx is continuous. Step number 1, f bracket 0, and we have the value of y which is equals to 1. Next, number 2, limit when x approaching 0 for the function fx exists and approaching negative 1. Step number 3, f0 is equals to limit when x approaching 0 from the fx. So the answer is not equal. So we can say the fx is not continuous at x is equals to 0. Then continue. Fx is continuous at this part. So fx is continuous at the situation interval negative infinity until 0, 0 until infinity, where the 0 is not included. So that is the situation. Hello everyone, in this video I'm going to discuss an example for limits and also the asymptote. Given the function fx, where we have the square root x cubed plus beta 5 over x minus 2. By finding the limits at the appropriate value, obtain the horizontal and the vertical asymptote if they exist. Kindly refers to the fx, and we notice that x cannot be equals to 2 if we substitute where we will have undefined. So limit when x approaching 2 from the left for the function square root of x cubed plus beta 5 over x minus 2. So 2 from the left, let's say we have 1.9999. If we substitute the value, and we will have a positive value for the numerator, and if we substitute 1.999 for the denominator, and we will have a negative value. So limit when x approaching 2 from the left for the function fx, and we will obtain a negative infinity. So meaning that the graph going up or going down as approaching 2 from the left. So for here, we are decreasing, going down as approaching 2 from the left. Next, limit when x approaching 2 from the right. For the function, we have the square root of x cubed plus e to 5 over x minus 2. If we substitute 2 from the right, for example, 2.0001, and we will have a positive value for the numerator and also a positive value for the denominator. Limit when x approaching 2 from the right for the function fx, and we will have a positive infinity, which means that graph will be increasing as the x approaching 2 from the right. So from here, we can make a conclusion. The vertical asymptote is x is equals to 2. So that is the vertical asymptote. Next, we are going to find the horizontal asymptote. So limit when x approaching negative infinity. For the function, square root of x cubed plus with a 5 over x minus 2. So try to imagine we have a negative 100. So if we substitute a negative 100, and where we will have indeterminate form. So from here, what we can do is to divide with the highest power of the denominator where we have the x. So for this case, we have to factor out the x. For example, limit when x approaching negative infinity. So over, we factor out the x. So here we have 1 minus 2 over the x. For the top, we have the situation x. So here we have the x to the power of 3 over the x squared. Plus, we have 5 over the x squared. As we can see, the square root of the x squared where we have the x. So simplify, limit when x approaching negative infinity. So here we will have the situation x plus 5 over the x squared over 1 minus 2 over x. So 5 over infinity, we will have 0. Same goes to 2 over infinity, we will have 0 as well. So for this case, we will have this part, we have a negative infinity. Square root for the negative infinity, which means that does not exist. So if we refer to the calculator, we will have math error or undefined. So meaning that there is no horizontal asymptote as x approaching negative infinity. So next, we are going to try on limit when x approaching positive infinity. Repeating the same thing, so make use of this part. So we have the square root of x plus 5 over x squared over, we have 1 minus 2 over x. So if we substitute positive infinity into this part, so very obvious, we will have a situation where we call positive infinity over 1. So for this case, we will have the situation positive infinity. So again, meaning that the graph will going up. So for this case, limit when x approaching positive infinity for the function fx, there is no horizontal asymptote, or we can say does not exist as well. So no horizontal asymptote.